Hi everyone, welcome back to Data Mining Video Lecture Series. This is Dr.Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. And in this lecture, we are going to discuss two non-parametric methods. Previous lecture, we already covered the two methods. Those are histograms and clustering. In this lecture, we are going to discuss sampling and data cube aggregation. So the sampling is one of the very important method to represent the data in a reduced form. So let us see. So first we need to understand why we need to do the sampling. So from this diagram you can simply understand, and there is a population. So in natural the population, the size of the population would be very high. Like suppose if you take India population or the population in a particular city so the size of the population would be very high. So in such a case, if you want to conduct a study to estimate some parameters related to the population, so it is very highly impossible to collect the data. That is, like suppose let us say there are 10 million population, so it would be very difficult, infeasible to collect 10 million the data from this 10 million population. So in that case, we'll go for a subset of a population, and that is referred as a sample. So here in this, we are going to discuss how this sampling would be done. That is different ways of sampling. We'll see some real-time use cases where the sampling will be used, and also the data cube aggregation. The sampling can be used as a data reduction technique. It can be used as a data reduction technique because so we are going to derive the insights from the samples, not based on the population. So that's why it reduces the data size, that is a larger data sets to be represented by much smaller data samples or subsets. So here these are the parameters. So most of the time we use mainly these are the population parameters on the left, and these are the sample statistics. The parameters related to the samples we used to call it as a statistics. So because the most of the time it is very difficult to collect the data from the entire population, so we'll go for the sampling. So what are the various sampling methods, so that we'll understand which is more effective and which is more appropriate. So the first sampling method is a simple random sample without replacement. The short name SRSWOR, and the sample size is small s. So here from this there are two terms like the random sample and without replacement. So we are going to collect a subset from the entire population. That is, we are going to select the random, and also we are not going to replace whatever the sample we selected in terms of the tuples. So that tuples would not be replaced. Okay. So here this is created by drawing S. This is a subset of n tuples from the database D. So here the S is obviously less than or equal to n. So with the probability of drawing any tuple in D, that is equal to 1 by n. That means each tuple or every tuple has equal chance of being selected. So from this diagram you can understand that. So these are the tuples, tuple 1, 2, 3 and so on, tuple 8. So by using this simple random sample without a replacement, so we are going to select the 4 tuples, and this is a sample. So let us see another method of sampling, that is the simple random sample with a replacement. So in the previous case, that is the simple random sample without replacement, and there is no possibility of getting the same tuple again. But in the case of selecting the random sample with the replacement, that means once we select a random sample and we are going to replace it, so there is a possibility to select that the same sample again. So that's why this is similar to the simple random sample without replacement, except that each time a tuple is drawn from the database D, that is data set, it is recorded and replaced. So once we record, it would be replaced, so that the tuple is drawn and it is placed back so that it may be drawn again. So, and this is the simple random sample with a replacement. So the 4 tuples been selected as part, that is the size of the sample is 4 here. This is the way we would select. So the next sampling method is a cluster sample. So if the tuples in the D are grouped into M mutually disjoint clusters, so then SRS of S clusters can be obtained where S is less than M. So sometimes a population would contain the 2 or 3 or n number of kinds. So in that case, to ensure that the representative sample is selected from the entire population, so this would be the one suitable approach. So clustering, so that the similar attributes would be like segmented into a cluster, so that we can select the sample from the respective clusters. So the sample which is obtained, that would be the more appropriate sample. For example, tuples in a database are usually retrieved as a page at a time, so that each page can be considered as a cluster here. So a reduced representation can be obtained by applying the simple random sample without replacement to the pages. So that results in a cluster sample of the tuples. For example, if you take a spatial database, so we may choose to define the clusters geographically, so based on how closely the different areas are located. So here from this you can see there are the different clusters. From this we could select the 2 clusters. Next, another important sampling method is a stratified sample. So if the D is divided into mutually disjoint parts, those parts are called as a strata. So a stratified sample of D is generated by applying the simple random sample at each stratum. So the stratified sample would help to ensure a representative sample, because this is very, very important. Whatever the sample we are going to obtain, we are going to create, we are going to select, and that should represent entire population. So that is mainly when the data are skewed. And here you can see this. This D, this is referred as D here. So it has many tuples, and from this you can see there are different categories like youth, middle-aged, and the seniors. So according to the age, we would select, like suppose there are 4, and then the 50% would be selected, and here there are 8 middle-aged people. Among this, 50% would be selected, and similarly here also the 50% would be selected. And from the seniors, again the 50% would be selected. So, and if you take another example, like let us take our college. So let us take the CS and CSD department. So there are some designations, like there will be some designations like professor, associate professor, and assistant professor. Suppose if you want to conduct a survey or if you want to collect a feedback, so that is more useful to if you could analyze it. So in that case, so let us say there are 100 faculty members in the department. Among these, professors, associate professors and assistant professors are there. So in this case, we cannot simply use like a simple random sample with replacement or simple random sample without a replacement, because here the data points in this D, this data set, are mainly categorized into the three groups, like the professor categories, associate professors and assistant professors. So we cannot randomly select. So if you could select the samples randomly like this by following either first or the second approach with or without replacement, then there is a possibility like a sample would have most of the categories are professors, or the most of the categories are associate professors, or most of the categories could be belongs to either professors or associate professors. So that's why in this case we have to group, and we can this stratified sample or the cluster would be the more useful sampling method to select the sample from this 100 members population. So what are the benefits of a sampling? There are various benefits of sampling, mainly the practicality, the time efficiency, because as we discussed in the very beginning, if the population size is very high, like let us say some 100 million population, and it would be very difficult to collect the data from this 100 million population. So collecting and analyzing the data from entire population is often a time consuming. So the sampling, in this case, the subset, we are going to select a subset, and that should be a more representative so that we could easily manage. Next one is a cost reduction. So that gathering the data from a sample is significantly less expensive than collecting the data from the entire population. So next benefit is a feasibility. Like large populations, in cases where the population is vast or infinite, for example, online user behavior, the sampling is only the feasible option. Next, data accessibility. Sometimes accessing the entire population would also be very impossible, such as surveying the rare species or a confidential data sets. So that's why this is a one benefit. Next one is accuracy and precision. So a well chosen sample, because that is very important one. The sample, whatever we select a sample, that should represent the entire population. Then we could call it as a appropriate sample. So a well chosen sample can provide a highly accurate insights into the population. Highly accurate. That means whatever the statistics derived, the sample statistics derived corresponding to the population, those represents the values are highly correlated to the entire population, that represent the entire population. So next, the statistical methods helps to ensure that the samples represent the population, that is minimizing bias and improving the precision. Next, another benefit is a better analysis. So we could focus on the details mainly with a smaller representative data set. So we can perform the deeper and more complex analysis. Next, we could avoid the overwhelm, that is handling large data sets can be computationally expensive and lead to the errors. So the sampling would obviously reduce the computational load. Next, on a last benefit of this sampling is real-time decisions. So in dynamic environments, mostly in like stock markets or online recommendation systems, the sampling helps us to make the decisions quickly by analyzing the smaller or real-time data sets. Like for example, because here in the stock market data, the stock price would continuously dynamically changing. So it may not be possible to capture the entire data within the window. so that sometimes we have to select the sample mainly in when the data is arriving in the form of a stream. So the stream of data, that means we do not have any control, the control that is to tune the speed. So we cannot even store this data. So we have to, let us say, and this is a window, we could able to process the data within this window, right? So once the data is reached this, and then it has to be discarded. So here the main limitation, main resource limitation would be the time here. So time is very limited here, and also the computational resources, the storage also very limited. So here the sampling will helps to make the decisions quickly by analyzing the smaller real-time subsets. So let us quickly see a few examples to understand a little more about this sampling. So like market research, the scenario would be a company wants to determine a customer preferences for a product. Here the population is the all customers in a city, for example 1 million customers, and here we perform the sampling, that is the company surveys 1000 customers using simply a random sampling. So here the purpose is to analyze the preferences without needing to reach the entire population. So let us see another example of real world example is healthcare studies. Here the scenario, the pharmaceutical company is testing the efficacy of a new drug. Here the population would be all patients suffering from a specific illness. So here the sampling, that is to select the 500 patients using a stratified sampling, because we have to concentrate on there will be different age group of people. So we have to use the stratified sampling to ensure the diverse representation. So the purpose is to estimate the drug's effectiveness while minimizing the cost and time. Another example of sampling is education performance. So like the scenario would be a school district wants to evaluate the student performance in mathematics subject. Here the population would be all students in the district. For example, there are 50,000 students would be selected as a sample. Here the sampling, we choose 5 schools randomly and we evaluate all students in these schools. So then this sampling would be the clustering. So the purpose is to assess the performance without testing every student. Another example, mainly most of the time we use this the sampling approaches, sampling methods like manufacturing quality control. Here the scenario, a factory produces 10,000 widgets daily and wants to ensure the product quality. The population would be all widgets produced in a day. So the sampling, so we inspect 100 widgets every hour using a systematic sampling. So systematic, that is another category. That means we are going to pick every 10th widget. So here the purpose of this is to detect the defects efficiently without testing every widget. So in any manufacturing, the quality control team will not check the every product. So they will systematically pick up the samples and they would test it. Next, another very interesting one is a political polling, that is exit polls. So a polling agency wants to predict the outcome of an election. So here the population would be all eligible voters. For example, there are 5 million people. So then the sampling is interviewed 2000 voters using a random sampling. This is also sometimes may not give a more accurate results. So this should be a more representative sample. So let us take one simple example, like let us take one city here. So there are city, there in city like different areas in the city. So let us see each area has some councillors or some representatives. So this through 2000 let us collect let us say there are 100 representatives, right, in this city. So and if we collect the information from this representative, and if we could predict the outcome of election, And then because this is the sample from this entire population we have selected, and this sample is a more appropriate sample, so the accuracy of the prediction would be more instead of simply interviewing the 2000 voters randomly. Next, the social media sentiment analysis is another example in a real world scenarios. Mainly, we want to analyze the sentiment, public sentiment about its brands on Twitter. So here the population is all tweets mentioning the brand. So we collect the 1 million. Let us say there are 1 million tweets. They are mentioned. They are talking about the brand of this company. So here we select. So 1 million. Sometimes it would be very difficult to process. Suppose if there is a time limitation, it would be very difficult to process within the specified amount of time. So in that case, we would collect 10,000 tweets using a systematic sample, like for example, every 100th tweet, then so it to gauge the overall sentiment without analyzing the every tweet. Next, another one is environmental studies. Here the scenario is the scientists want to measure air quality in a city. The population would be air across the entire city. The sampling, that means we could place the sensors 20 representative locations. So that is stratified sampling by industrial, that is by industrial, residential and commercial zones, etc. And the purpose is to estimate air quality levels citywide. So the 20 sensors, because we deployed these 20 sensors in representative locations. Next one is another data reduction, that is to represent the data in a reduced form is a data cubes. This we discussed in data warehouse mainly. So let us try to understand what is a data cube first. Then we'll see the benefits of how it is going to reduce the data, multidimensional data. So a data cube is a multidimensional array or a structure used in a data warehousing, mainly online analytical processing. So to organize, analyze and summarize the data, it's primarily used for a multidimensional data analysis, which enables the users to view and explore the data from multiple perspectives. For example, let us take a sales data cube. So it has the dimensions like a product. Under this product, we have the categories like a laptop, smartphone, and a tablet. Under the time, we have year, quarter, and month. Under the location, we have the country, state, and city. So here, this is an example of a data cube, the graphical representation, but this in a physical, it would be represented in the form of tables, etc. So in this, from this data cube, we can understand that. So there is year dimension, item type, and branch. Under the branch, there are 4 categories A, B, C, D. Under the item type, the security, phone, computer, entertainment, and home. And the year 2008, 9, and 10. So each cell gives the aggregator value. So here this is another example from this. You can see this is a textbook example of Hannon Camber. It represents the sales data for a given branch of all electronics for the years 2008 through 2010. On the left, the sales are shown for the quarter here. So on the right, the data are aggregated to provide the annual sales. Like here, these are the year-wise sales, so that if you want to get the annual sales, so that is, it would be aggregated. So the cubes created at the lowest abstraction level, that is referred as a base cuboids, whereas the cubes represented at the highest level of abstraction, those are called as apex cuboids. So the data cubes created for varying levels of abstraction, those are often referred as cuboids, so that the data cube may instead refer to the lattice of cuboids. So each higher abstraction level further reduces the resulting data sets. Higher abstraction levels means if you could come back to this one, like, or you can take the example like month is a lower level of abstraction, then the quarter is a next higher level of abstraction, and year is a highest level of abstraction. So the each higher level of abstraction, right, when we are moving from the lower level to the higher level, it reduces the data size, because here we will be having a 12 months. So 12 months data. Here we'll be having the 4 quarters, and here 1 year. So this is the way it reduces the data set size. So let us quickly summarize what we discussed in this lecture. So the data cube created at lowest level of abstraction is referred to as the base cuboid, and at a high level of abstraction, that is apex cuboids. So from each higher level of abstraction, that further reduces the resulting data sets. And coming to the sampling complexity is potentially sublinear to the size of the data mainly. And the other data reduction techniques can require at least one complete pass through the data in order to find out the sample. For a fixed sample size, the sampling complexity increases only linearly as the number of dimensions increases. The number of dimensions means number of attributes, and these are the number of samples. So number of samples, and these are the number of features. These are the number of features. So this is so if the number of features are increases, the dimension of the data set would also increases, and the number of samples also increases. But most of the time, this is going to have a huge impact on the processing. So when applied to the data reduction, the sampling is most commonly used to estimate the answer to the aggregate queries. So thank you for watching this video.